So, what's the deal with AI in the classroom? You hear it all the time. Is it a total game changer or just a fancy crutch for students? It's a huge debate. But, instead of just talking about it, what if we could actually test it? Well, today, we're diving into a really cool study that did exactly that. They put AI to the test in a real-world classroom to see if it actually helps students learn.
All right, here's how we're going to break this down. First, we'll set up the big question. Then, we're jumping straight into this fascinating case study out of Sri Lanka. We'll look at the actual data, see what kind of a learning boost AI gave, and then, and this is key, we'll explore why it wasn't the same for everyone. And finally, we'll talk about what this all means for us.
So, this is really the heart of the matter, isn't it? On one side, you've got people saying AI is like a personal tutor for every single student, on call 24/7. But on the other side, you've got skeptics who are worried it's just a super high-tech way to cheat that actually gets in the way of real learning.
Yeah, that's the bottom line. Is this a tool that genuinely helps build skills, or is it just a shortcut to the right answer without any of the understanding? To figure that out, you can't just guess. You need some cold, hard data.
And this is where things get really good. Instead of just speculating, a group of researchers decided, you know what? Let's run an actual experiment and get some real answers.
So let's get into it. The setting for our story is the University of Kilauea in Sri Lanka. Researchers there got together with a group of undergrads to measure the real impact of using generative AI.
The study group was made up of 57 students from the Industrial Management Department. And it was a pretty diverse bunch too, a mix of genders, ages, and different years of study. But here's a really important detail. They all had different preferences when it came to coding languages. Keep that in mind, because it's going to be a big deal later.
The way they set this up was just beautiful in its simplicity. First up, a pretest, to get a baseline. Where is everyone at with their coding skills right now? Then, for the second test, they let the students use AI to help them solve problems. And finally, a post-test with no AI to see what they actually remembered. It's a perfect way to see what effect the AI really had.
So, the experiment is done, the tests are graded. What did they find? This is where we get to the really juicy stuff, the core results. And wow, the data tells a pretty clear story. Check this out. Before using AI, the average score was about 11.5 out of 18. Then, when they brought in the AI for the mid-test, that score jumped to nearly 14.5. That's a huge leap. But here's the most important part. In the post-test, without AI, the score stayed high, around 13.6. That shows more than just a performance boost. It suggests they actually retained the knowledge.
And you don't have to take my word for it. The researchers themselves were pretty direct about what this initial data meant. It showed a clear, positive impact on the students' coding skills.
But they went even deeper. They wanted to put a number on just how effective the learning was, and that number was 0.33. So, what does that mean?
Well, it's something called the end-gain value. It's a standard metric in education research to quantify learning. And the score like 0.33 is considered a medium learning gain. In plain English, that's a solid, statistically significant sign that real, actual learning was going on.
But here's where the story gets a little more nuanced. When you look at the individual students, it's not quite so simple. Yeah, the overall trend was great. 2/3 of the students saw a real improvement. But look at this. About a quarter of them didn't improve at all, and some even did a little worse.
And that brings us to the next absolutely crucial part of this whole thing. That positive impact from the AI, it wasn't a universal experience for every single student. The researchers started to notice that things like what year a student was in, or even which programming language they liked to use, played a really big role in how much they actually got out of the AI tool.
Okay, just look at this table. It is fascinating. Second-year students saw a pretty decent learning gain, but the fourth-year students, a much lower gain. Why is that? Maybe they were more set in their ways? Who knows? And get this, the programming languages, C++ users saw a huge learning gain, while the C# users, barely any benefit at all. This is such a critical insight. One size does not fit all, not even close.
All right, so what's the big takeaway from all this? Let's zoom out from this one study and think about the broader implications here.
So here's the bottom line. On one hand, we learned that yes, generative AI can be a seriously effective teaching tool. It can create a real, measurable boost in learning. But on the other hand, we learned that its effectiveness isn't a guarantee. The impact really depends on the student and the situation.
And of course, we've got to be responsible here. The researchers themselves pointed out the study's limitations. It was a small group, only 57 students in one department. So while this is a fantastic piece of the puzzle, it's not the final word. Think of it as a really important starting point for more research.
And that really leaves us with this final big question. This study suggests that maybe we should stop asking if AI can teach. The data says it can. The much more interesting and way more important question now is this: how do we design and use this incredibly powerful technology so that it lifts up every student, no matter what their background or experience level is? That is the real challenge ahead of us.